Hello everyone, welcome to the video. Today I will reverse engineer a laptop's proprietary motherboard and its firmware and port its keyboard drivers into Linux. As I see, there isn't a lot of content about laptop reverse engineering or some kind of hardware reverse engineering. Let me introduce you the laptop. So I have a Casper Excalibur G870. Casper is a laptop brand that is locally popular in Turkey. So if you don't live in Turkey, you probably don't know who is Casper. Excalibur is a sub-brand of them. It manufactures relatively cheap gaming laptops in Turkish electronics market, consumer electronics market. You can see the specs right there. So the problem with Casper is it doesn't have broad community support. As I see, the manufacturers doesn't care either. In the most of Linux apps, you can't control its keyboard LEDs. So I will show you how. Anyways, we are on Windows 10 right now for debugging. Let's see the app first. Okay. So as you can see, there is fan speed, CPU or GPU fan. But the thing is, I won't deal with display mode today. This is for GPU switching. As you can see, the keyboard consists of three parts: Zone A, Zone B, and Zone C. There is some lighting modes, and there is a color wheel, and there is also brightness. And yeah, that's it in the LED control part. You can select all. As I said, we can go to debugging. So the first thing I want to mention is, in most of the videos about tech or reverse engineering, they don't show you how to fail part. I will show you how to fail part, so you learn by failing. So the first instinct you can see is you can search right there. So this is the category. You pick laptop from there, and this is the series. You pick the model, and it gives you the drivers, etc. Control center app. As far as I know, it works for all of them. I mean, because the EC layout is the same. So anyways, the first instinct you have to check is if you can't its source code, you can just decompile from an app called Ghidra, IDA Pro, whatever you use, it doesn't matter. Finish. Okay, so the first thing you could check is apps exe file. So you get from not there, get from there. So you just drag there. It automatically sees what does it consist of. Okay, and you double click this, and it starts to decompile. It analyzes, as you can see. So you can see the source code somewhat. I mean, you can go to the main functions if you say, and you can see there isn't a main function, but there is a function for discrete mode or maybe event mode, and you can see it is .NET code and C# code. I mean, these apps, both Ghidra and IDA Pro, their purpose is not disassembling C# code, so you use something called DNSpy. Okay, that's interesting. This is maintained one. As you can see, it's a fork, and this is unmaintained one. So as you can see, we failed, but we learned that it is made with .NET. So this is the point of failing. You learn by failing. Let's go on DNSpy. There will be some things when you open it first. You can just hit file and close all. I open the control center. Okay, as you can see, you can reach from there. And we have some functions. MyLED func, data LED group. This is for NVIDIA GPUs. This is not relevant right now. Disk usage, fan control, blah blah blah. So the first thing I would check is the function that is hooked with button. There is LED zones. There is select all, select, not select all, etc. Okay, so let's search for zone, and yeah, is single zone boolean is there, current zone is there. This is byte, yeah, not boolean. Okay, this is, yeah, there is probably an enumeration called 0, 1, 2, etc. or maybe 3 for all of them. Let's click this. It says 5. Okay, I don't know what does it mean. There is set LED mode, but these are not really meaningful data. So we can just actually, there is a breadth mode, right? We can just write breadth and it doesn't show. Let's write solid. Okay, let's write mode. Ambilight. There is a constant. There is an enumeration called ambilight. Off, static, breathing, colorful cycle, and ambilight. Okay, these IDs might be relevant. So let's just open a text document and write these on. Oops. Where is it? Okay. So I can just copy and paste this actually. This should be relevant. The fan is not relevant. These are not relevant either. My let func. Okay, what is that? This is a short func. And this is just a getter, I guess. Yeah, this is just a getter. Not a setter. We need setters. The last thing we can do is the working part. Read and write everything. There's a software called Read and Write Everything. It can be sketchy, but it's not actually. It is a really old software that is dates to 2007, I guess. Yeah, there you can see 2007, 2006, 2005. Okay, it dates to 2005. It's a really old software, but it's very convenient. If you are working on EC debugging, I mean, there's a lot of things you can debug. I mean, if you are working on GPU drivers, you can use PCI device, PCI data, or maybe something like that. If you are working on USB buses, you can use this, or maybe you can use Wireshark. I don't know. So the thing is, when you are debugging low-level registers, your PC can freak out. Your brightness can change. If you are using laptop, your trackpad might not be functioning for a short time. I mean, these are in general stored on its short-term memory. So if you restart it, it goes back to normal. So there should be EC. Okay, you can see there is a lot of registers. There is 256 registers, and you can adjust the refresh timer. We need something fast, so 200 milliseconds is fine. So the first thing we should do is the filtering the so fast registers. I just unmonitor that. Unmonitor. This should be enough, I guess. Okay. Okay, this should be enough. Right? Yeah, probably. Okay, let's... can you get me to let control? I mean, yeah, it freaks out right now. Let's select all. And let's deal with LEDs. Okay, can I get a paint? So, you have some registers. Let's say that's red, green, and blue. Okay, so as you can see, we store them in a 8-bit integers. In example, if you set the keyboard to the full red, you should get something like this: FF0000. If set to full blue, you get FF0000. Oops. Okay. Yellow, you go FF00, and etc. So we should seek 3 consecutive registers. Let's set this to red. It's red. And you can see, let's set this to blue. It is not set to blue right now in my keyboard. So as I said, it barely works. Okay, it's blue right now. As you can see, these 3 consecutive registers represent the values. It should be FF00 or something like that. Yeah. So we found the registers. I mean, you can find it easily in general. But I want to keep that video short. These are our registers accordingly. So in general, in these apps, there is a commit button. But in this app, there isn't a commit button, so you just guess it in a hard way. Let's see the commit button or apply button, which register could be. In these apps, there's a default state and set state, write state. So it doesn't write eventually. So we should seek a form that goes some number and turns back to the default. So let's see. Okay, some things happened there, but I couldn't catch really well. The AC is commit button. As you can see, it goes 08 and 02 or 0A. It should be 8, not A. Yeah, as you can see. But the app is freaking out right now. I'm waiting for it to commit on my keyboard. My keyboard is still green as the previous color. Yeah. Okay, as you can see. So the commit default is 02. Okay. These are nice discoveries. Okay, let's work on the zones individually. We couldn't see anything related to zones. So let's not select all, and as you can see, there is something happened in our commit button. It went to 52, 58 and 52 for a brief second. I mean, it happens in a fraction of a second, so yeah. This still, yeah, 0 is enumeration for all zones, not just one zone. So we can just say, let's go on B. The app is stuck again, and you can see it went to 4, 8 for a brief moment. So let's set this to 4. Probably C is 3. Yeah. Okay. The only thing left is these patterns. So let's see the breathing. If something changes. It is not breathing in my keyboard right now. There is some change in T1, E2 and EB, I guess. Yeah. E2 mirrors EB or vice versa. Let's call it. Let's go for breathing. It is 3. Okay. And let's go for colorful cycle. It is 6. As you can see, it matches there. This was the thing I would like to talk. 6, and let's go for Ambilight. Okay, let's see the Ambilight. It's not on Ambilight right now. Okay, it is 7. Okay, there should be a commit button too. Let's see. As you can see, it just adds 1. So 0xC1 static 11 breathing 31 blah blah blah. So the only thing left is to go on Linux and program that. So see you on Linux side. Hello everyone. So we are on Linux. So let me open the terminal and Helix just touch script py. Helix script py. Okay. Let's set our constants. Reg red. I didn't show you the brightness register, but it's 0x64. I will just write it down. It's not a big problem. 1 0xEB reg mode 2. Remember, these two mirror each other. The EC path on Linux is this. Let's write the EC path. Sys kernel debug ec0 io, and let's write the zones. This will be an array, this will be an array, so I will define this like that. Okay, so this is our zone comments. I will just write this, and we can maybe set some color presets, and let's call it yellow. Up 255 2550. Okay, this is nice. By the way, this is not a programming guide, this is a reverse engineering guide, so if I make some mistakes, I'm not a Python expert, it happens. Let's set our modes. Okay, this is nice. And let's set a current mode. Solid. Okay. Okay, so the first function we need to write is readEC. Okay, so this is our readEC command, and we have to write it too. So def write EC of value for safety. I mean, you are dealing with EC, you have to play safe. Okay, so the main problem with Excalibur's original app was there wasn't a apply or trigger button. So let's set up trigger button. Def trig zone data. Okay, so this is our trigger function. As you can see, it inits first, then commits, then states. So let's make a function that takes a user input and sets the keyboard colors. Okay, so as I said, these functions are respectively to the RGB layout. So let's make an apply mode function. Okay, so the helper functions are done. Let's make our main function. I will just write if name equals main. Okay, this is our main function. Let's set a while loop. While true. Okay, while true. Let's try. Let's set a variable called action and get some input from the user. So let's strip if there is any space remains and set this to lowercase. If user inputs exit, let's break. If user inputs a color, let's get another input called color name. Color name in colors. If color is valid, let's take a zone name input from the user. And if zone is valid too, let's set the color and zone. And let's actually send the data. Set call. And let's put the else's. And let's make the same thing for effect too. Okay, so our script is done. As I said, this is not a good practice, but I just want to show it. Import sys. Okay. Okay, I debugged a bit and we forgot to accept. Okay, so you have to write this before writing something into EC, and you just sudo python 3 script py. Let's say color red all, and it's red right now. It's nice. And let's say effect breath, it is breathing, and let's say maybe effect cycle, it's cycling, and let's say exit. Okay, I guess this is it for this video. As I said, this is not a programming tutorial, so I don't recommend this way, but this is the fastest way you can try. So see you on the next video.